My name is Andrew, and tonight we're going to talk about Azure DevOps. So here's the agenda for tonight. We're going to talk about what Azure DevOps is, what its core components are, and how to tailor Azure DevOps to your workflow. So what is Azure DevOps? Well, let's just start with DevOps. What is that? The goal of DevOps is to streamline and automate the software development and deployment process, ultimately leading to faster delivery of software, increased reliability, and improved collaboration across the entire lifecycle. So Azure DevOps is a software as a service platform which offers a set of tools to facilitate this lifecycle. It offers a range of tools for planning, developing, testing, delivering, and monitoring software projects. Azure DevOps helps development teams collaborate effectively, automate processes, and ensure the continuous integration and continuous delivery of their application. Now let's talk about the core components of Azure DevOps and how they relate to the software development lifecycle, starting with Azure boards. Now, in the software development lifecycle, it's important to plan before you start building something. This is where Azure boards comes into play. At its core, Azure Boards is a comprehensive work tracking system that provides teams with the tools they need to plan, track, and manage their work effectively. The platform supports various agile methodologies like Scrum and Kanban, enabling teams to plan sprints, backlog management, and visualize work items progress. So if we go to our Azure DevOps dashboard here, and we go to Azure Boards, from the work items feature, you can create tickets for features, improvements, or bugs. You can then assign this ticket and track it in the Kanban board, which is another feature of Azure Boards. From the Kanban board, you can review your tasks and tests for each item. Using backlogs, you can plan your sprint by dragging and dropping an item to the desired sprint. Once in a sprint, you can use the sprint board to track your progress. Azure Boards can also seamlessly integrate with other Azure DevOps services. For example, if an engineer starts a task here, they can create branches for their work right from the board. This brings us to our next service, which is Azure Repos. Now, after all the planning is done and you've written some code, you can use Azure Repos for version control and source code management. Azure Repos supports Git, which is the most popular version control system out there, and can host your source code very similarly to other popular code repositories like GitHub, GitLab, or Bitbucket. Azure Repos also supports centralized version control with TFVC if you want to use that. So if we go to Repos and we go to Files, we can navigate our repos content and even make quick edits. Commits allow you to see how all of your branches come together. Pushes give you a historic view of all the changes pushed to the remote repo, while branches allow you to review all the branches and see if they are ahead or behind main. And using the pull request page, you can review and participate in pull requests like you would other popular Git-based code repositories. So we've already planned and written our code, and now we need to test, build, and deploy it. This is where Azure Pipelines comes into play. Azure Pipeline focuses more on the CI/CD, or continuous integration and continuous delivery of the software development lifecycle. So if we break this down even further, let's take a deeper look into just the CI pipeline, which incorporates testing and building. So if we go back to Azure DevOps and we go to the pipeline section and we edit this pipeline, we can see that pipelines can be written in YAML, which means you can have your pipeline script as part of your code. And the main building blocks of these Azure pipelines are steps, and each step will execute a certain command. For example, we may have steps to package the application, build an image, run tests, or push that image to an image repository so that it can be deployed later. And here we have an example pipeline for building a Node.js web application. And as you can see in this example, we execute these build and test commands with these script attributes. However, we have another option for executing step commands instead of scripting it directly in YAML ourselves. In addition to writing scripts, you can use what is called a task instead. In Azure DevOps, you have a plethora of tasks already available to choose from for different use cases, and they can be selected and configured using this UI. You can select a task directly from the list of available tasks on the right side of the pipeline's YAML editor and configure any needed parameters for the task. And when you have the task configured, you can add the task back to your YAML pipeline. And you can also adjust or add any additional configuration to it. So for example here, if we look for a Docker task, we can find one for executing various Docker commands like build, push, login, logout, start, stop, etc. And once configured, you can add the task in the script. Let me just add the task there. There you go. And this can be convenient in many use cases because you don't have to know the commands exactly, and you don't have to memorize the exact syntax for the pipeline. So this basically gives you a simpler and easier approach to adding steps to your pipeline. So overall, the main task of this CI pipeline is to test the code changes, and if everything is fine, produce an artifact that we can deploy. And speaking of artifacts, before we get into the CD or continuous delivery side of Azure pipelines, let's talk about Azure artifacts. So what is an artifact in this context? An artifact is any kind of file or files that your build process produced that you may want to reuse in another build, in another job, or in a deployment pipeline. Now, depending on the application programming language, this artifact produced will be different. It could be a jar file for Java application, a NuGet file for .NET application, or a zip file for a JavaScript or NPM package. And we use Azure artifacts for storing these artifacts that were produced in the build pipeline. Now, if we take a look at our dashboard here and we go to artifacts, we can see some of the artifacts that are supported. And as you can see, we have NuGet packages for .NET, NPM packages for Node, Maven for Java, Python for Python, and Cargo for Rust. Now, in modern software development, instead of these language-specific packages, usually a Docker image will be created as an artifact instead. And while Azure Artifacts isn't a Docker image registry, Azure does offer its own built-in container registry, and it also provides the ability to connect with external container registries such as Docker Hub. So now that we know what artifacts are, let's pick back up where we left off in Azure pipelines. So we've seen how to test and build our application, and now it's time to deploy this to the end environment. This would be the next stage in the pipeline, which is called CD or continuous delivery. So now that we have this second stage, we're going to need to define this stage in our YAML file. So if we go back to pipelines and we open this other YAML file, we can see that it has two stages, one for the build process and one for the deploy process. And here we can use a specific type of job called the deployment job, which handles the deployment commands. Now, when we are deploying a new application version, we usually don't directly deploy to production. Instead, we deploy to intermediate environments. We test it extensively and we gradually promote it to production. It's common to have development, testing, and production environments. And when you have multiple environments for multiple applications, it may become difficult to have an overview of what version or what branch is deployed where. And that is where the environment features comes in. We can create environments in Azure DevOps, which will map to the actual deployment environments. And then you can configure in your pipeline which of these Azure DevOps environments you want to deploy to. And once the application gets deployed to these various environments, you can view the deployment history per environment. Plus, the deployment status can also be linked back to the original tickets, so you have that additional information for the future. So up till now, we've had our CI and CD pipeline together in a single YAML file. But Azure DevOps actually allows us to separate our CD pipeline with the releases feature. So the way it works is if we go to releases here and we edit this release pipeline, we need to choose an artifact, and we can select a build pipeline that produces an artifact, or we can choose an already built artifact from another source. Then we can create a release pipeline for that artifact. Note that release pipelines in Azure DevOps can only be created using the UI. So there is no YAML file for this. However, the pipeline structure itself is the same. You can create steps by choosing from available tasks, and you have multiple stages like deployment, testing, and production. Now let's move on to tests. So Azure DevOps has a dedicated component for tests called Azure Test Plans. And here you can create a unified central view of all the test cases that need to be checked before giving a green light to production deployment. And here you can create manual test cases so that when a new feature is being released, a tester can go through the steps and manually test the application. But this could also be automated tests, which will be executed as part of the CI/CD process. And as you can see, if we go to test plans, here we can see the tests that we have created. And if we go to the progress report feature, all the test reports for our pipelines can be published and viewed here. The main advantage of this is that you have a centralized place with an overview of all the test plans, whether these are automated that will run in the pipeline or manual tests from developers, product owners, testers, etc. And you can even view and run test cases related to a feature directly from the Kanban board. Great. So now we've seen how all the main components of Azure DevOps map to different parts of the application development lifecycle, starting from planning the task all the way to developing and deploying it to the end environment. Now, I would like to mention here that while Azure DevOps offers a plethora of features, you're not obligated to use every single one to gain value from the platform. One of the beauties of Azure DevOps is its adaptability and its modular structure. This means you can pick and choose the components that align with your team's workflow. For example, if you're primarily interested in automating your deployment pipeline, you can focus on Azure Pipelines and ignore the other components. Also, Azure DevOps isn't limited to the Microsoft ecosystem. It's designed to work and integrate with a variety of technologies and platforms. This means you can use it with GitHub, GitLab, Jenkins, or even other cloud providers like AWS. This enables you to create a deployment environment that suits your team's unique requirements. So Azure DevOps is not a one-size-fits-all solution, and that's where its strength lies. And here you can see a couple of examples of this. On the left, we have Azure Pipelines used with a GitHub repo and Kubernetes. On the right, we have Azure Repos and Azure Pipelines used with AWS CloudFormation and AWS Lambda. So in conclusion, we talked about what Azure DevOps is. We've explored the integrated components that make up Azure DevOps, and we witnessed how they can collectively enhance and improve the development lifecycle. And we also talked about its modular structure and how you can tailor it to your workflow. And with that, I would like to thank you all for joining me tonight to delve into the world of Azure DevOps. Here are some of the references I used. And here is my contact information if you'd like to reach out. Thank you.